Imagine your manager asks for a list of the company's top customers. To find them, you can't just pick a random dollar amount as your baseline. You need to figure out what the average customer spends first, and then isolate everyone who exceeds that dynamic number. To solve this dynamically, we use a subquery. It operates like basic algebra, nesting one query inside another using parentheses. The database engine solves the innermost parentheses first to find the dynamic average and feeds that numerical value outward to evaluate the main query. In the script, the logic is clear. We have our standard select statement at the top, but down in the where clause, the nested select statement is working in the background to isolate the average lifetime value. While subqueries elegantly solve that first dynamic filter, they create a bottleneck as your logic expands. If you needed to add 3 or 4 more steps to this process, each one would have to be wrapped in its own set of parentheses. You eventually end up reading the code from the inside out, making it difficult to debug or follow the logical flow. When you nest too many subqueries, you end up with syntax soup. The logical steps get buried under layers of parentheses, hiding the actual intent of the analysis. Modern enterprise analytics solves this using a common table expression, or CTE. You can think of a CTE as a temporary staging area that lets you write a complex query, give it a name, and then treat it exactly like a real table for the rest of your script. Instead of wrapping logic inside out, CTEs let us take those nested algebraic layers and flatten them out into linear, sequential steps. Looking at this script, we initiate this staging area using the with clause. By typing with customer totals as, we are packaging the logic inside the parentheses into a temporary dataset that we can easily query later. If your data requires multiple layers of processing, you don't have to stop at one CTE. You can chain them together, treating your code like a factory assembly line, where data flows continuously from one discrete station to the next. In our scenario, Station 1 takes the raw customer and order data, merges it, and groups it to calculate the total spend for each individual person. Here's the code block that builds that first station. Notice the comma right after the customer_totals parentheses. That comma is the connector that allows us to chain our first block directly into the next CTE, ranked customers. By separating tasks into distinct blocks, you move away from tangled nested structures and begin architecting logical, physical data pipelines. Before we look at the next block of code, consider our final goal, finding the top 3 customers. Since Station 1 already calculated the total spend, what calculation must happen at Station 2 before we can isolate those specific leaders? We need to assign a numerical rank to those totals. To do this, we rely on a tool called a window function, specifically using the rank command. Look at how a standard group by operates. It takes detailed data and collapses it down into a single summary row, removing individual details. But the rank function analyzes data without squashing it. It sorts values and applies a ranking calculation, leaving rows perfectly intact. Returning to our script, you can see this in action at Station 2. We pull the customer name and total spent from our first CTE, and then we introduce the rank function to evaluate those totals without losing our distinct customer details. Window functions are critical because they allow you to append advanced calculations to a dataset without permanently sacrificing granular, row-level information. Let's watch the entire logical pipeline run from start to finish. The raw tables are fed into Station 1, where the data is joined and aggregated into total spend per customer. Those new totals instantly flow down the belt into Station 2. The window function evaluates the amounts and assigns a ranking number to each individual customer row. Finally, the stage data hits our actual select statement at the bottom of the script. This query acts as a gatekeeper. It evaluates the new rankings and ensures only the top 3 records reach your final report. Looking at the completion of the code, the rank function sorts the total spent in descending order. Then, outside the staging area, our final query simply filters for any rank less than or equal to 3. This is your new toolkit. We use nested parentheses for single dynamic filters, conveyor belts through CTEs to chain multiple datasets, and ranking stamps to preserve row integrity during complex analysis. By mastering these components, you move beyond simply pulling raw data. You are now architecting scalable, multi-step analytical pipelines that can handle the most complex business questions.